Hello, everyone. Welcome back, or welcome if you're new here and you have never met me, had a lesson with me, or seen me before. My name is Kate, and I will be talking you through some organic chemistry today. So, when it comes to organic chemistry, it's really important to understand that it is at first overwhelming, and fundamentally organic chemistry, the reason why so many people struggle with it is because it's overwhelming. There's so much that you need to remember, so many different connections you need to make, and that's valid. It's completely valid to feel overwhelmed about organic chemistry. So, in different videos, what I do intend to do is break down organic chemistry, talk more about the theory, break down alkanes, alkenes, carboxylic acids, all of that kind of stuff. But what's important for now, especially because the exam is coming up next week. Is it next week already? My goodness, it's next week already. What I intend to do is basically to be able to take you through some questions, take you through how I approach questions, maybe give you some insights, and ultimately help you to feel less overwhelmed. So, obviously, when it comes to organic chemistry, when it comes to me, let's start with that. Obviously, when it comes to me, I am just a human. And because of that, I would like to have a disclaimer in this video. And that disclaimer is that I am awful at spelling. So I'm very good at maths. I'm very good at chemistry, but I am extremely bad at spelling. So basically, if I spell something wrong, call me out in the comments below, roast me. I don't care. Well, I do care. Please don't be mean. This is little me here trying to help. But yeah, and also I would like to say that because I'm very new to this, I am so sorry if my camera quality is not great, my audio quality is not great. I will be working on that very soon. I just want to prioritize getting some videos out before the exam to be able to help as many people as possible. So if you enjoy this video, give it a like, maybe subscribe to the channel if you'd like to see more content from me, and hopefully I will be able to teach you something today because, I love teaching. Okay, cool. All right, so let's get into it. So basically, we are doing organic chemistry today. The idea with organic chemistry, as I mentioned briefly, was that it's about overwhelm. So at this point in your journey with organic chemistry, you should have at least got a relatively good idea of the different homologous series and the different functional groups, and hopefully you've been studying what makes what, who reacts with who, what makes what, all that kind of snazzy stuff. But it's important to be able to apply that knowledge. What I always say to all of my students, and they can attest to this, is that it's not just about memorizing your information, it's about regurgitating the information as well. And the word regurgitating does sound pretty gross, but you have to vomit all that information out on the piece of paper and make sure that the examiner can understand you and that you understand yourself as well. All right, so what we're going to basically do today is just go over a couple of example questions, as I said, and I'm going to go through some of the more detailed work. So if you are struggling still with the basic stuff, please reach out to me in the comments and I'll hopefully find time to be able to make a more in-depth video on the specific topics. But it's a little bit of a broad look at everything today, so that you can maybe apply some of the knowledge I give you to your own exam. What I'm going to do is just go through the questions and answer them for you, and basically talk about my thinking behind each of the questions. Okay, so we've got question 1. So the question 1 says, the diagram shows a reaction sequence starting from ethanol. All right, so what we have to do when we first start a question, and I always say this, is you don't want to immediately go and now draw the displayed formula of P. Your eyes shouldn't go from here straight to here. Okay, because what that does is it creates, again, the overwhelm. You don't want to overwhelm yourself. So what I first do is I first like to make sense of the information given to me. So I go from here to here. Okay, so let's zoom in a little bit so that you can see a little bit better. So basically, here it says, again, the diagram shows a sequence starting from ethanol. So ethanol, if you have studied more and studied and understand, will know that that's an aldehyde. So that basically means that here we are looking at an aldehyde. All right, so an aldehyde is now reacting with HCN and NaCN, which is reaction 1, and is forming P. So I, at this point in the exam, shouldn't have even read this question yet, okay? But instead, what I'm going to do is I'm going to ask myself, what is P? What knowledge do I know about aldehydes and hydrogen cyanide, and how do they react, and what is P going to be? So you ask yourself that question. I'm investigating the diagram. I am not answering questions, because the second you ask yourself questions, you start influencing your answers. What you want to do is you want to be able to process all of the knowledge you have before you start spitting it out. Okay, so if you have studied, you will understand that ethanol, your aldehyde with hydrogen cyanide, is going to create what we call a hydroxynitrile. All right, so let's write that out. Oh, that's my eraser. Hydroxynitrile. Again, if I spell something wrong, oopsie, and my handwriting's not amazing, so I hope you could read it. Okay, so basically we produce a hydroxynitrile, which contains which functional groups? Again, it's always about your functional groups, because your functional groups are the things that react. So we have a hydroxynitrile. The hydroxy is your OH functional group, or your alcohol functional group, and your nitrile is your CN functional group. All right, now this molecule is undergoing reaction 2. Reaction 2 is then basically forming a carboxylic acid. Now, how do I know that's a carboxylic acid or has a carboxylic acid? It's because of my, what I call COO. Okay, your COO molecule. If you see a COO or a CO2H, that is your carboxylic acid. However, we still have our hydroxy here. So again, I haven't even looked at the questions. I'm just investigating the reactions. So somehow my cyanide has turned into a carboxylic acid using sulfuric acid. All right, we understand that now. We are not making any assumptions. We're not jumping to any conclusions. We are investigating. I'm going to say that a lot in this video. Okay. Then basically, what's happening with reaction 3? So in reaction 3, we still have our COO molecule, our carboxylic acid, but we no longer have our alcohol. Our alcohol is turned into an alkene. Now your brain must immediately think, well, how? How does it turn into an alkene from an alcohol? Well, this, if you have done your studying, you'll know that this is a dehydration reaction. And the reagent that we use is a catalyst. So we use a lot of heat and we use a catalyst of either a concentrated acid or aluminium oxide. All right, so we've got our concentrated acid or our aluminium oxide catalyst with a lot of heat, which will dehydrate the alcohol into your alkene. Again, I've already answered a question because I know my stuff so well. Again, that's why studying is important, but I know my stuff, but I'm not looking at the question yet. All right, let's do the last reaction. We've got reaction 4 here. So with reaction 4, what's happening is, again, I still have my carboxylic acid. So something has turned my alcohol into a ketone. Now, it's really important for you to start being able to recognize your functional group. So definitely go through papers and make sure you're identifying what the functional groups are, especially in skeletal formulas, because those can be really difficult to identify. All right, so we are now looking for something that is going to turn an alcohol into a ketone, but it's going to keep the carboxylic acid. So remember, if you have done your research, again, alcohols can turn into ketones via an oxidation reaction. Okay, because what's happening is the O is we're losing an H. And remember, a definition of oxidation is loss of hydrogen. So because we are losing the hydrogen in the O and forming a double bond, it's an oxidation reaction. Now we have two different oxidizing agents. We can either use potassium manganate or we can use potassium dichromate. Now, which one are we going to use? Now, the real answer is it actually doesn't matter. Whether or not you state potassium manganate or potassium dichromate, it doesn't matter. But for alcohols, we usually use potassium dichromate because of an obvious color change. And we'll go into that a little bit more when I have a video on alcohols. But the idea is that we're going to be using potassium dichromate, but we must remember that every time we use an oxidizing agent, it must be acidified. So we're going to be using acidified potassium dichromate. And don't worry about the potassium, you just need to state the chromate ion. For some reason, my pen doesn't like going past this point, so I'm just going to draw it over here. Chromate. There we go. Okay, all right, acidified potassium dichromate. All right, so can you see I've now scribbled a whole bunch on my diagram, but I've understood my diagram. Now I can go into the question. So the first question basically requests us to draw the displayed formula of P. So before we answer the question, let's just quickly double check what a displayed formula is. Now remember, displayed formula means you have to show all the bonds. Okay, not just some of the bonds, all the bonds, if you want to make sure you get your marks. So we've already figured out that we are forming a hydroxynitrile. So you already know that you're going to have a functional group of OH and a functional group of CN. And if you know your mechanisms, what you'll understand is that the double bond breaks in your ethanol, the CN will bond and the H will bond to the O. So basically, if we were to answer that question, we have a C, we have an OH at the top here, showing all our bonds. I just said that and then didn't do that. Whoopsie, naughty Kate. So we have OHH, then we have our cyanide ion, which is a triple bond. Okay, just remember that cyanide is always a triple bond, and then we have our CH3. Okay, why is it an H and an H3 on the other side? Well, that's because that's what it had. All right, so don't forget to investigate what it had. All right, and there is our displayed formula of P with our OH and our cyanide. All right, name the type of chemical reaction that occurs in reaction 3. So let's go back to reaction 3 and see what we said. Well, we've already established, I never wrote it down, but I did say that it's a dehydration reaction. Now, I already know that because I've already investigated the question. I'm not trying to jump around and think and trying to, where's reaction 3? I've already written down that information. So now I can just write it on the line. Dehydration. All right, then it says, write an equation to represent reaction 4. Use O to represent the oxidizing agent. All right, we already established that it's an oxidation reaction. Good for us, that's some confirmation. So we just need to be able to understand what it is making, which we've already established is we're going from our alcohol with a carboxylic acid functional group to a ketone with a carboxylic acid functional group. All right, and remember this is a ketone, not an aldehyde, because the C that the double O is bonded to two other C's, which makes it a ketone. All right, so we draw our reaction. So we're starting with, so I'm scrolling a lot, I hope that this is not an issue for you. So we're starting with our CO2H, H3, I've covered the 3, but that's a 3CCHOH. All right, so basically what we're going to do is we're going to start by drawing our chain. So our longest chain is the C3. Okay, So it says write an equation to represent 4. So we're going to do this in a structural formula. Most of the time when you have to write an equation, you have to do it in its structural form. So we're going to draw CH3, which was the guy on the end. So I just need to keep jumping back so I can see. Then we have the COHH. So basically what we're going to write is our CH and then in brackets OH, just to show that that's the functional group. And then at the very end, we have our COOH. I like to write it as COOH because I like saying coo. Anyway, okay, so basically we have this information. All right, then it's already said that we represent our oxidizing agent with O, which we can do. So what we have now is we have our carboxylic acid and our oxidizing agent with our alcohol. So remember, the oxidizing agent is going to affect the alcohol, not the carboxylic acid. So what do we create? Well, we've established that we create a ketone. So let's draw the ketone, okay? So the ketone is going to form where the OH formed, and it's going to create a double bond. Now, as you can see here, that removes the entirety of the O and the H. Well, not the O and the H, but the H. But it also removes this H over here. Okay, so what we're going to do is we're going to draw this. You can investigate it to see how it works, but basically we just have CH3, which is on our end. Then we have the COC, which we'll not say out loud, otherwise I will get demonetized, and then we have our double bond OH. And again, my thing is not letting me do that. Let me draw it over there. There we go. All right, okay. But what else is made? So we've lost 2 H's and we've added now, we haven't added an O, but we've got an O. So we can kind of figure out what molecule has 2 H's. Well, H2O. So even if you're not entirely sure what the other thing is, investigate what has been lost and what's similar. So I'm just going to draw it here because I don't, as I said, my thing is being stupid, but H2O will be your other molecule. All right. And then it says state the reagents and conditions required for reaction 4. Well, aren't we so clever? We've already figured it out. Acidified potassium dichromate. All right. And what I want you to understand is that another quick tip, is that all oxidation reactions are heated under reflux. So we can say acidified, I have to spell like that, acidified potassium dichromate, 2 minus, and then it must be heated under reflux. All right. Whoa. So I hope just doing this one question with you helped. If you would like me to do more questions, if you would like me to do any other topics before your exams, again, please let me know down in the comments below. And then, I hope you have a fantastic rest of your day. And most importantly, good luck. Thank you.